So these are some old gussets for the first time I tried doing the control arms. Okay. I don't like the angles of the bends. They're too sharp and they're the wrong angles. Okay, so I've since had new ones laser cut out, but I don't want to use those for testing to see if I can bend it. So what I'm going to do is I took a piece of, I think it's 1 inch. It was just 1 inch bar, roughly that length. So I cleaned it up on the lathe a little bit, and then I put it in the mill, and I just shaved, I don't know, 40 thousandths off the top of it, just to give a flat spot to make it easier to weld that cup. And now that I think about it, I got to turn the inside of that cup open just a hair so that it'll fit up on the press. And if I like how it bends, then I'll drill and tap a hole in the side. That's easy enough. I may do that anyway. So anyway, I'm making a bending jig. I turned that piece down, cleaned it up on both ends. So now I'm going to blast it with the MIG welder. As you can see, I've just got a welding blanket sitting there just so I don't have to move everything. Yeah, that ought to hold. Certainly for testing. I just want to put a thumb screw 1/4-20, something in here that I can snug down to hold it up on that thing. So, and instead of 1/4-20, it's going to be an M6 because that's what happened to be in the thing already. I got a lot of M6s. Alright, close enough. Let's go bend something. Okay, always a bit of a challenge getting back here to with the bender. Okay, now I'm wondering, I should be able to turn it at whatever angle I want, so I've got enough room there. So I'm kind of thinking, it's got a welding thing right there, so yeah, that's close enough. I got enough travel there. Let's run it down and get it centered. Luckily these are my metric pliers. Ooh, moment of truth. I'm hoping that I'm not so limited here. I might have to try another piece, but I'm afraid of what might happen with this end, and it may slip off here, but this should be close enough. And I'm not bending a 90, okay? So it'll still be a bit of a challenge. I'll have to make myself some kind of reference jig, bend another rod or whatever, because I've got two different angles. One set, half of them go to one angle, and the other half go to another angle. So let's see what it does here. Oh, let's see if we can zoom in a little bit for you. That might work. This was with the sharp one that I did before, so I like that. That's a much softer radius. So that's going to do the trick. I've been designing a bending jig, and you know, I was like, oh my god, okay, I got to do this, put some rods in, blah blah blah. And it dawned on me, it's like, oh, what the hell? Why don't I just air bend the damn thing? And you know, I already had the bottom here, and I had already put a little bit of radius there. You know, so it does get a mark there, but I'm sure I can flat disc that off. Yeah, I'm pretty pleased with that. And this is super simple. I mean, this took me a whole, 20 minutes. Okay. That's what I was afraid of. Once you start bending, they pinch in there. So, okay, that is going to be on there like that. And granted, obviously, the position's not going to be correct. So I mainly want to line up. Yeah, so I overbent it. And that's the sharper of the two bends. But I think the radius is going to look pretty nice. You know, it matches better than that for sure. Alright, let's bend another one, and maybe not quite so far. Oh. Okay, this time I'll show you the grinder. Alright, so one of the advantages of having a belt grinder, depending on exactly how it's set up. When I did this, I intentionally left this spot open here, knowing that, you know, you couldn't bend the 1/4 inch here or whatever, but what it does, and I've done it too up here, you know, if you need a softer grind or whatever. This belt's worn out bad, but, you know, still takes metal off. Oh, I got really close. I'm going to like that. Alright, one more, why not? I got it sitting here. Let's call that pretty dang close. Yeah, it might not be perfect, might need a little tweak, but yeah. Sweet. Building the bending die stuff, I love making tools, but I got so much stuff to do. It's like, man, I really didn't want to take the time to have to build a fancy jig. So, yeah, nice. And this is the kind of thing that Mike at District Fab, he's got a CNC'd press brake, and you know, I could take him over there and he could probably just program it bump and whip them all out in a couple of minutes. I may consider that for next time, but for right now I got to get them bent. Yeah, I'm gonna have to drill the holes out. See if I can get the right angle on it here. Alright, see the curve there? It's not quite 90 degrees. The bottom sticks to the left just a little bit more. Okay, well, if that happens in holes that are really tight tolerance, you know, I don't like to go much smaller, because then the laser really has a hard time cutting holes smaller than that. Basically, the hole should have been 3/8 of an inch, at least is the diameter of the thickness, because it gets so much concentrated heat in there and slag and everything like that. The inside of the holes don't come out quite as pretty. Water jet would be perfect. Water jet's still got a kerf. But if I want this kind of tightness, this kind of fit, then basically I need to just plan on drilling them. And that would actually make the parts a little bit cheaper. So this is the top side, and they look perfect. Yeah, the holes have a slight angle to them too. So, and that's basically just because of the what I showed you there with the kerf. I guess that's not the kerf. Did I call it kerf? Draw. I don't remember what the hell the word is for the taper, you know, because it's going to be nice and clean up at the top, and then it's going to flare out just a little bit. If you look here, see how there's really no heat marks? I mean, really, really tight heat zone right around the hole. But if you look at this side, see the bigger heat zone? That's going to be the exit side. Okay, so another way to look at it here when you're looking at the side, okay, this is what I'm calling the top. Oh, this is what I'm calling the top here. Let it get in focus here. This is what I'm calling the top because there's no heat affected zone. So if you look at it here, see how the bottom has that big swoop drag? So the laser was coming along, you know, from this side and cutting. And just like with a torch or even water jet and stuff like that, you know, it moves along like that, and as it cuts, it actually slows down a little bit. If we look at this end again, if we can, the bottom is in a little bit, okay, because the cut widens as it goes down. Oh yeah, I think you can see it here pretty good. See the taper to the cut there, which isn't much of a big deal, especially on straight lines and stuff like that for a part like that. But when you get inside the hole here, and it knocks the hole off. Well, that one looks pretty good that way. Dumbass. Alright, get it focused in here. Not sure if you'll be able to tell, but it has a slight lean to the right. The top of the bolt here is over to the right just a little bit. And, you know, a lot of times wouldn't be much of an issue, but since I've got the tolerances so tight, I am going to need to open those up. And I will definitely make a point to take those holes out of there and just drill them next time. You can have a laser do a punch mark, basically, just to ideate. The problem is, though, is that it creates a hardened spot. And so then, you know, your drill bit's going to have a harder time getting in there. Alright, it doesn't take much to drill these out, and I definitely want to come from this side because the heat affected zone is smaller. So the more heat there was, the harder that's going to get. And this is, you can see that's actually the uglier part of the hole, so I want to get up here where it's nice and accurate. Might be spinning a little fast. 5/16 just went right through, so this is the next size bigger. I didn't check, maybe there's a letter size in between. But I've only got one set of letter drills, and I don't like using them for this kind of work. I want to keep them for, you know, when I need a nice hole in a nice piece. I wanted to give you a little comparison. These are the marks left by when I did the bending, okay? And if you remember, I said something about taking a flat disc or whatever and grinding them down. Well, I just hit them on my belt grinder, okay, just to knock out the heavy stuff. And then once you go through the sandblaster, you know, I didn't do anything to this side, just left it like that, put it in the sandblaster, so that's going to be perfectly fine. I might have to do that pinch a little bit there. Yeah, I'll need to grind that open on the belt grinder a little bit. I got the wrong abrasive on there right now. So, excuse me. But anyway, I thought you'd like to see how that's going to come out by the time it's all finished. Now I'll grind these down now because it's easier to get them now. But I'm not going to do the sandblasting until after they're welded together. I think I'm about ready to tack that one together. Yeah, actually I suppose I should probably do a little wire wheeling and just make sure that it's HRPO, but just to make sure the surface is clean where I'm going to weld it. I could either glass bead it, sandblast it, or wire wheel it. Food's almost here. I can't maintain this fine because he's passing on a meal, so